In this video, we are going to look at the volume of revolution and how it relates to some integration questions in IB Maths exams. So what we did learn with integration earlier is that if we have a function, for example 2x squared, and I'll quickly draw what 2x squared looks like. It'll be a positive quadratic that's been stretched 2 units. If we integrate our function, let's say 2x squared, between limits of 2 and 1, so we have these x values here at the top and bottom of our integral, this means that we are actually finding the area underneath of our curve here between when x equals 1 and when x equals 2. So when x equals 1 and x equals 2, if we go up to our curve and we find this area, that is going to be an area which we can calculate using the definite integral. Now, what this topic then does is we want to find the volume if this area is revolved, or it's the volume of revolution. If this is rotated around this x-axis the whole way, 360 degrees. And it's a little bit hard to draw, but I'll try and draw what this will look like. It'll be now like a cone. It'll be a three-dimensional shape where this would come out of the screen, then back into the screen, and we would have this cone where you could speak into this side and it would come out this side. And we can find the volume of this three-dimensional cone, this three-dimensional shape, using the volume of revolution formula. And it is very similar to the area formula for a definite integral. All that is different is there's a pi in the equation and we need to actually integrate our function squared. So they're the only two changes to turn this two-dimensional area into a three-dimensional volume. So let's do that for our example. I'll do it by hand and with our calculator to show you that the calculator is very handy in this topic. So if I want to find the volume rotated around the x-axis, if we use this equation between the x points of, let's say, 1 and 2, so the volume, this will equal the integral between 1 and 2, so 2 and 1. And we have our pi. Now in the equation here, they have the pi after the integral. You can also have it at the front here because pi is just some constant. So you can put the pi here. And then we need to have our function in here that is being squared. We can't forget to square our function when we're finding the volume. It's a common mistake students make. They forget to square their function. So this will just be pi times the integral between 2 and 1 of, this will now, if we square our function, be 4x to the power of 4 dx, our power of the 2 and our x squared. And then we just do a normal definite integral with a pi at the front. So we will have our integral, which is 4x to the power of 5 on 5, with the limits of 2 and 1. Now, there'll be some fractions here, but let's just work our way through it. We'll have pi. Now, we sub in our 2 first, so it'll be 4 times 2 to the 5 over 5. Subtract 4 times 1 to the 5 over 5. And the pi will multiply by whatever this gives us. Okay, now 4 times 2 to the power of 5 is 32. 32 times 4, this will be 128. So 128 over 5. And then we do subtract. And 4 times 1 to the power of 5 is just 4, so 4 over 5. So as a fraction, we're going to get 128 minus 4 over 5. So 124 over 5, and we have our pi. So 124 pi over 5. And this would be the answer if we did not have a calculator. And what this answer is similar to what I drew before. It's the volume underneath this shape, underneath this curve, between 1 and 2, if we took this area and we rotated it around this x-axis 360 degrees. Now on our calculator, these questions are typically in a calculator exam, so we can solve it just by going pi multiplied by our definite integral between 2 and 1 and we'll have our function, which is 2x squared, and we need to square this, and we just have a dx at the end. Okay, so 77.9 will be our volume. That will be the same as this, hopefully. I'll just check. If we do 124 multiplied by pi over 5, it's the same volume. So this would be the decimal answer. This here would be the fraction answer. Okay, so these questions, they aren't too hard once you understand the formula. It's just a slight adaptation of the area formula. You may get questions where you need to find out what these 2 points A and B will be, and that's usually points that we can find using our calculator. So try and practice at least 2 or 3 of these questions and you should feel pretty confident with this topic. Okay, good luck.